Okay, good afternoon, everyone. It's very nice to have you all here with me today. I'm Norman Huang, and today I'm presenting about real-time streaming classification with Storm, and we are coming from Yahoo Taiwan e-commerce data team. This is me. I'm a data engineer of Yahoo Taiwan, and I focus on build system and using data mining algorithm to retrieve data insights and to deliver those insights via business intelligence platform. And this is my teammate Jason. He's also here with me today. And he's a cloud developer, and he's responsible for implementing algorithms for our recommendation systems. And also, he is specialized in Pig and Hadoop MR programming. In our presentation today, there are three major parts. First, I'll talk about the background of us, which is Yahoo Taiwan. Second, I'll talk about the challenges that we are facing now. And finally, we will propose a solution, Pinball, to deal with the challenges. And then we will have Q&A session to open up for questions. So if you have any questions, please hold your question until last session. As you all know, Yahoo is an internet portal. And we offered search results, news, sports and financial information, etc. According to Alexa statistics report that Yahoo is the top one site in Taiwan. And as you all may know, there's a student protest going on in Taiwan. And we have lots of up-to-date news on our Yahoo website. And this is the daily habit of Taiwan users. Okay. But actually, we are more than an internet portal. APAC is the best region for Yahoo to run its e-commerce business. And we've covered different business models with the following major e-commerce properties. In 2001, we've launched auction. It's more like eBay. We provide a platform and for our customers to sell products to each others. And in 2004, we have shopping mall. Shopping mall works like Amazon. And we own the platform and we sell products to customers on our own. Finally, in 2008, we've launched shopping mall. Store market, sorry. And store market is kind of like a virtual department store. We provide a platform for our vendors to sell products and to our customers using our platform. And with the coverage of different kinds of e-commerce properties, that makes us, Yahoo is the leading e-commerce company in Taiwan. Since we've got our first mover advantage in 2001 after we launched auction service. As you can see from the right-hand side chart, this is Taiwan retailer market. And I put those purely e-commerce company in red box. So you can see that we have several competitors like PC Home or EHS. But there's a few companies which earn more revenue than us. But they are actually bricks and mortar shops. Why is that? That's because Taiwanese consumers tend to feel and to touch those products before their purchases. And we have lots of convenience stores just around the corner. So our consumers can purchase what they want very easily. But what those retailers don't have is data. They are only capable of collecting and analyzing those transactional data. But as the internet portal, we are able to collect all kinds of user behavioral events, such as click streams or view information, and the time spent. That means how long did you spend on our website. And with the development of data science, we are able to have better understanding of our users' behavior. And this could be an unique strength to enlarge ourselves and to make us the biggest retailers in Taiwan. Okay, now let's take a look of challenges. Currently, we use batch trend recommender to provide product recommendations. You might wonder what exactly is batch trend recommender. This is Amazon website, and when you are browsing a watch on Amazon, it will provide also both products on the bottom of the web page, and this is a item-based recommendation. And so do we. We provide also viewed and also bought module at our shopping mall website. So when a consumer is trying to browsing a laptop like this image, then we can use the following modules to provide similar products or any products that he might think of to buy it, okay? And how the batch trend recommender works. We've collected the data and persist it in our storage. And when a specific time is reached, then we will launch a batch job to analyze those user log within a specific time range, usually 2 weeks or 4 weeks. It depends on the algorithm you implemented. However, the outcome of batch trend recommender is somehow a static content until next batch job runs. So we might encounter a situation is that the recommendation may be somehow a little bit outdated when we offer to our consumers. Okay. And what's more, the batch product recommendation algorithm has been adopted and to become common features among competitors. That makes us to think if we can figure out something more, something special, so we can one-up other competitors. And based on our findings of internal data research, we found that nearly 80% of our visitors made their decision at the same day. So if we can identify our potential buyers as soon as possible and to deliver proper recommendation to them, maybe we can convert most of the consumers to our buyers. So we have proposed a real-time solution so that we can interact with our potential buyers and encourage them to make their purchase to buy our products. Okay, so this is our solution, Pinball. And as you can see from the image, this is a Taiwanese traditional pinball machine. When you fire a ball, and it will eventually fall into a specific slot. This is the inspiration of the name of our real-time solution. So let's take a look of how our pinball works. Users represent balls, and classifiers represent pins. And we can classify our users according to their browsing events. And it will eventually fall into a specific profile. Let's say if 2 users have been put into the same profile, that means they have similar buying preferences. Okay, real-time, pinball is a real-time classifier, and by using pinball, we are able to detect buyer's preference by streaming data processing, right? And with the ability to identify our potential buyers, then we can deliver personalized ads and product recommendation on the fly for this consumer. So here's the challenge of Pinball. The first would be how to do it in real time. And then how to determine our consumers' buying purchase. How to determine our consumers' purchasing desire. Means the intention of this consumer to buy our product. Since the Pinball is built on top of Storm, so I will give you a quick overview of Storm. Storm gives us the functionality to process real-time data streams. And then we will use what's called buying intention to determine the purchasing desire of our consumers. And then I'll talk about the architecture and design of Pinball. And finally, we will have a demonstration of our Pinball and to see how it works in real life. First, let's take a look of the concept of Pinball. With the analysis of our transactional data, then we can know that the patterns behind those purchases. Let's say if a visitor decided to purchase our product, and this event would be sending to Storm, and the learning module will take that event, that buying signal, and start to retrieve the hidden patterns behind these purchases. And with lots of buyers, we are able to detect all kinds of the purchasing patterns of these purchases. And with this knowledge, we can use it to identify and to detect our potential buyer. If a visitor browsing our e-commerce website, and he's considering about purchasing our product, and the browsing event will keep sending to Storm, and we can further leverage the result of our learning module to see if this visitor is our potential buyer or not. If this visitor is our target customer, then we can deliver appropriate promotions to this consumer, and we can further convert this visitor into a new buyer. So this is Pinball. For example, if we analyze all the laptop buyers by using the learning module, then we can retrieve the purchasing patterns behind those laptop buyers. So with the knowledge, we are able to detect future laptop buyer. Then if a visitor comes in and he's trying to search laptops on our e-commerce website, then we can use this knowledge coming from learning module and to see if this visitor is our potential buyer or not. Okay? Then if this visitor is our potential buyer, then we can deliver the right product recommendations to this consumer, or we can cooperate with our vendors so that we can provide special offers to this consumer. And then with the right product recommendation and promotions, we can convert this visitor into a new buyer. Okay, since Pinball is built on top of Storm to do real-time data, streaming data processing, and here I will give you all an overview of Storm. Storm consists of two major parts, which is spout and boat. A spout is kind of a data source, and it works like a faucet. When you switch it on, and the water will come out. And the water itself represents data streams. And we, developers, and we can implement business logics within the boat. And the bot will take those data streams emitted from spout and to perform certain calculation based on predefined implementations. And it will pass the outcome to another bot. And finally, we can have the end result of the whole calculation. And with spout and bot, we are able to form a complete storm topology. Take workout as an example. Spout will emit an article line by line, and the bot will take the sentence emitted from spout and split it into words. And then here we will calculate the word occurrence of this article. And then finally, we can have the word count of this article. This is very similar to Hadoop MapReduce job, right? But the main difference between storm topology and Hadoop MapReduce job is that Hadoop MapReduce job will finish eventually. However, storm topology runs forever unless you kill it. So it's focused on continuously data streaming processing. And here, I will going to talk about buying intention, which we use to identify and to detect our potential buyers. Based on our findings of internal data research, we found that the more page views of a specific category, the higher the chance this visitor will buy this product. But the buy intention value of this category, of each category, will vary. For instance, it takes 2 times for most of the buyers to decide to purchase cookies. However, it takes 6 times for most of our buyers to decide to purchase a TV. Since the TV is much more expensive than cookies, so it makes sense that people will think twice before they purchase a TV. And after we talk about storm and buying intention, here I'm gonna talk about how we leverage storm with buying intention. And this is the data flow of Pinball. Navigation event streaming will collect all kinds of browsing events generated from our e-commerce website. And the behavioral event itself has 2 types. If this visitor decides to purchase our product, then this is a buy signal. Then we will pass it into our learning module and try to retrieve the patterns behind this purchase. And if this visitor is still considering buying our product, then it's a view signal. Then we can leverage the outcome from learning module and to use it in our buying intention qualification module to see if this visitor is our target customer. And let's talk about the upper part, which is learning module. And if we received a buying event when a consumer decided to purchase our product, then we will collect related information and pass it into our adaptive learning module. And then we will start to retrieve the patterns behind this purchase. And then we will have our learning module, our learning results. And here we're implementing an online learning perceptron algorithm, which is used for supervised classification. And it maps the input X to an output variable, either 1 or 0. So it's a binary classifier. In our case, our classifier will, if it emits 1, then this visitor is a potential buyer. If it returns 0, then this visitor is not our target consumer. And this is the formula, simplified one formula to describe the buy intention concept that I described before. Okay. In this formula, we will only have to pass into the original buy intention of this category, and then pass the how many page views before this consumer decided to purchase this product. And this algorithm is a gradient descent algorithm because we want to keep it simple and easy to calculate. For example, if we set gamma value to 0.1, and the original buy intention value of this category is 3. If a new visitor comes in and he decided to purchase this product after 6 times of page view, and according to our formula, and we will collaborate the new buy intention with this formula, and the new buy intention value will be 4 after this calculation. Okay, so after we talk about how we retrieve the buy intention value, which is the threshold, we determine this visitor is our potential buyer or not. Okay, then if a visitor is considering buying our product, and all the browsing event would be a view signal, then we will collect related information and pass into our classifier. And here we will base on the return value coming from our classifier and to determine if this visitor is a potential buyer. And then here, the buy intention qualification, we will try to deliver appropriate promotions or a special offer or product recommendations to this client if this visitor is our is our potential buyer. Okay. Then after we talk about the logic of adaptive learning and buy intention qualification, here's the topology design of Pinball. By implementing navigation spout, here we will emit all kinds of browsing events generated from our e-commerce website. And the event type itself has 2 types, like I said before, either buy signal or it's a view signal. And if a buy signal, then we will collect the related historical events of this buyer and sending those information to our learning bot. And according to our formula, we will collaborate the new buy intention value of this category and for our classifier to do further use. Okay, so if another visitor comes in and he's browsing our website, create lots of view signals, then we can collect his historical events, his logs, and pass into our classifier. And based on the output of classifier, qualification bot can determine if this visitor is our potential buyer or not. Then we can, based on his profile, and to deliver appropriate promotions to these visitors. And the notification here, we will try to deliver those product recommendations on our website, as you can see from the following demonstration. Okay? And after we finish the prototype of Pinball, we've observed that there's a serious problem. Because we are an internet portal, so there's lots of traffic going on. And we have a lot of invalid records, and that will affect our classifier dramatically. So we have to eliminate those invalid records so that we can have an accurate classifier. So here, in order to solve these issues, we are trying to remove out all the traffic generated from bot and those traffic with the forged IPs. Okay, so here's the updated topology that we put a blacklist filter right after our navigation spout. So here, we are trying to remove out all the invalid records so that the following bot will only have to deal with those valid records. And then we can have a more precise classifier to determine, to detect our potential buyers. Okay, so here let's take a look of how Pinball works in real life.
Okay. Thanks, Norman. Okay. So in previous slide, we talked about the topologies of storm, and in this demonstration is a video to demonstrate the scenarios of how we detect the user is a potential buyer or not, and how the topologies works. Okay. So in this video, there's a user is looking for a nice laptop. Okay. So he's now trying to connect to our shopping mall. It's our shopping mall in Taiwan. And he's trying to key the keyword laptop in Chinese in search box. And you can see the result page. He clicks the first one, and he goes to the item page. And you can see the red point represent the data flow, and it's a view event. Okay. So the user history ball will memorize how many times of this user view this category. Okay. So the user is still not decided yet. He's trying to view another laptop. Okay. So this is the second time. You can see the number is 2. Okay. So the third time. Okay. Okay. And at this moment, he's trying to make a decision. Okay, I want to buy this one. Okay, this is the purchase button. Okay. So after he clicks on the purchase button, the buy signal will send immediately into the learning board. And the learning board will collect how many times of the page view the user sent. And he will try to calculate the buy intention value, and we'll keep it. And then we will use later. Okay. So after we have the buy intention value 3, how we use it. There's another user is trying to look for a laptop. And also he keys some keyword laptop on the shopping mall. Okay. So he's still browsing, and the different scenarios, he's looking for the different laptop and look into the features and still considering. Okay, and this is the second one. And he's now browsing the second one. And he just considering to buy or not, maybe the price issue or the feature list. Okay, so the match time is the next time. So when he goes to the item page for the third time, the view signal will immediately send to the classifier, and the classifier will determine the user is a potential buyer because the number of the page view of this buyer match our buy intention value. So the classifier will pass a signal to the qualification board, and the qualification board will promote the specific offer to this user. And this offer is special for him to encourage him to buy it. Okay. So what if the user behavior changes? For example, the number of the page view before purchase changed from 3 to 4. Okay, so this user click on the buy purchase button, but his page view number is 4. Then we have to do some adaptive learning in our classifier. So in this case, the original buy intention value is 3, and the user page number is 4. So we will put these parameters into the formula, and we make an assume. We assume the gamma value is 0.1, and you can calculate the new buy intention value will be 4. Okay. So the next time, if a new user is trying to visit on our website, and he will see the promotion after make 4 page views. Okay. So in a demonstration, we only talk about the buy intention value, but we have to increase the user's engagement. But to increase the user engagement, we have to apply more modules on our system, which means we have to keep it generic and flexible. Okay, and this slide is an example that we would try to modularize the different kinds of components into three type of modules. And we mentioned before the view signal, the buy signal, and the buy intention value. But actually, we could onboard more signal on our system, just like the click event, or the login event, or the bounce, and even the spatial one, the web page sequence. Okay, and for algorithm, of course, we could onboard another algorithm, just like a fraud detection. So in EC, fraud detection is a special case. Is that fraud detection? The fraud is he's a real person. It's not just like the invalid record that we mentioned before, the blacklist filter. Blacklist filter is just a composite of IP. So we just ignore the list of IP, then we can prevent the attack. But fraud detection is difficult because it's more complicated. So if a user is trying to steal or to steal other users' accounts or steal their money, then they might have the different behaviors, just like a login time, the many login time from different locations, and maybe he have many accounts in one IP. And maybe he just provide a very low price for a computer, but after our buyers gave him money, but he just gone. Okay, so we can apply any online algorithms on our system. Okay, and of course for channels, we could apply more channels on our system, just like a messenger. We can reach our visitors by different ways, and by emails, or like we talked before, by web pages, and even more by mobile apps. Okay. So in the last slide, we are trying to sum up. Then the Pinball is built on top of Storm, and Storm provides the functionality of processing the real-time data, and also provide the scalability. So we can do the scalability scale. We can scale our system anytime, and it supports any kinds of online algorithms. We can implement different classifiers and based on our needs. Okay. So of course, it supports flexible interaction with our visitors because we have more channels. We can apply different kinds of channels. Okay. So with different kinds of channels, we can increase our users' engagement. And if a user is looking on our item page, and we can promote the specific promotion on the right time, we can also increase the conversion rate. Okay. So the last but not the least, Pinball is not just to replace the batch recommendation, but to create the synergy by combining the batch recommendation and Pinball. Okay. So any questions? Okay. Right here. Yeah, please. Yeah, please.
Have you thought about using a negative signal? Because it strikes me that you've got a pattern for a buy signal.
Yeah.
But what would be really interesting is when somebody loads the page 5 times continuously and then they don't buy. You know, I've thought about using that as a negative signal to sit there and say, why are these people not buying, but this group is buying? I'm thinking that would that not be stronger?
Did you mean that when a user viewed lots of times, but he did not decided to purchase that product?
Yeah.
And how do we do
Hi.
it, right?
Yeah, it was. Yeah, is it not a good idea to look at negative signals? So once you've established a pattern of buying behavior, would it not be a strong signal to sit there and try and find out why people that then view it 5 or 6 times don't buy, and try and find out patterns for those people? Because they would be a more, because a stronger would be to flip them from a no buy signal to a buy signal.
Yeah. If a user is trying to view our website lots of times of that category of products, then that can be an pricing comparison behavior, right? So if so, that could be a factor if that happened. So maybe we can try to analyze the price factor of our products, yeah, so that we can deal with this issue.
Okay.
I was wondering, how do you group products? I mean, I think you must have a notion that like this user is looking for a laptop,
Yep.
and so you count only the pages when the user looks at laptops,
Yep.
and not when he looks at bicycles. So do you have these product groupings? Do you feed them into your system in advance, or does it also automatically learn these groups?
Oh, yeah. We've leveraged the predefined taxonomy of our products. Actually, we have a product tree of our products. So we are using a category. So if laptop, different brand of laptop, they will be grouped together to a specific category. Yes.
Okay.
Yeah.
It just occurred to me because I saw like your first user in the video was looking at Toshiba and the second one was looking at Acer laptops.
Yeah.
So might even be different market segments, right?
Yeah.
Okay.
Thank you.
Questions?
Sir?
Sir?
Hi.
Hi.
I just wanted to ask you if you can go in more detail into the inputs of the perceptron that you are using.
The input.
Yeah, what kind of inputs go into the perceptron? Can you go into that?
Yeah, I can talk a bit of the input. Actually, we collect the user, which is would be encrypted, so it's somehow an anonymous format. And then we'll collect the category information and how many times of page views this visitor actually visit this category. Yeah, and of course we will collect lots of timestamp of this user logs. Yeah, and we calculate the buy intention based on those logs. Yeah, in order to get a new buy intention value. Yeah.
Thank you. And one more question.
Yeah. Sure.
I thought gradient descent is for batch learning. Is that not true?
It's for
Batch learning. Batch learning.
Oh, batch learning.
Yeah.
Oh yeah, because here we are trying to, here we use gradient descent algorithm because we're trying to leverage the characteristic of linear approximation provided by gradient descent. Yeah, but we are still trying to adjust the formula. Yeah, so it somehow works for us using gradient descent algorithm in our formula. Yeah.
Thank you.
Thank you. Hi, sir. Okay.
Excuse me, my voice is very low.
Okay. So it's okay.
So is page view
Yep.
in the same session or across time?
Yeah, it's cross time.
Across time.
Yeah. In our implementation, that we collect those user logs within 6 hours because we only focus on short-term behaviors. Yeah. Thank you.
Hi, do you record what users buy from a category and relate that to other categories? For example, when users buy a stove, maybe he will buy a fridge.
Oh, you mean the purchasing sequence, right?
Exactly.
Okay. Actually, we have an data research of batched buying sequence. Yeah, but we are still working on real-time buying sequence analysis. Yeah.
And not exactly when the same users in the same day purchases something, but a user purchasing something in a day and 1 week later he purchased something else, but the same user.
Mm-hmm. In our case, because we only focus on the latest 6-hour data, so if the transaction is cross-day, then it will be not calculated into our calculation base. Yeah.
Okay, thanks.
Thank you.
Haven't you tried to use this data to challenge with some logistics problems? For example, mining the IPs, looking for that kind of products, and eventually sending these products to this city before the buyer really start to buy. Predictive things using geolocation. No? Once more, okay.
Okay,
You've got a lot of data about the buyers with some IPs, and you see the trend. For example, these geolocated IPs always buy such kind of products. Don't you thought about using this data for logistics to first send there a lot of kind of that product, and before the buyer really come to you?
Yeah. I know. Amazon actually has the same patterns about this idea. It detects what users might purchase at that region, and at first deliver those goods to its inventory beforehand. Yeah, and yeah, that's an interesting idea that we can leverage in our system. Yeah. Thank you.
Thank you.
Do we have time on the clock, Hans?
Oh, no?
No? Okay.
Sorry.
Sorry, that was the last question.
Okay.
Thank you.
Thanks for listening.
Thank you.